Hello everyone, welcome to the second video of concurrency playlist. In the previous video, we covered the topic of concurrency and how we are solving it with the help of a single thread or a synchronized keyword in Java in our single system. But now we have reached to the problem when we have a distributed system and now we want to solve this problem. So for solving in the distributed system, we have the second point, that is distributed concurrency control. For studying this, we have to understand some concept first of all. For this, let's understand the first concept, that is of transaction. So transaction means that if we are performing any action on two rows, let's for an example, then what will happen? Before state of the transaction and after state of the transaction, the total summation is going to be same. Before result and after result should be same after the whole transaction. And if we got some error, the whole transaction will be rollback. So let's understand it with an example. So I have taken an example here that we are going to debit the money from X, we are going to credit the money to Y, and if everything is successful, we are going to say commit, like voila, everything is good. But if there is some problem in any of the step, we are going to roll back. Let's understand it with an example. So suppose I have two wallets X and Y. What is the initial state? That W1 is equals to 10 and W2 equals to 0. So let's take the initial sum. So initial sum is going to be 10 plus 0, that makes the total sum equals to 10. Now let's move forward in the transaction. What happened after that? We want to debit some amount from W1 and we want to credit some amount to W2. So this time let's debit the 5 rupees. So after that, like if we debit it means 10 minus 5, and that will make the value of X equals to 5. That means W1 equals to 5. So after state, so it will be 5 plus. Now what will happen to W2? We are going to add 5 rupees to W2. It means we are going to add 5 rupees to the Y person, and now the W2 will become 5 because the previously the amount was 0 and this time we added 5 rupees. So now after state equals to 5 and the total sum is going to be 5. So this time what we are getting, initial sum is equals to 10 and after sum is equals to 10. So we will say that our transaction is successful, hence we can commit it and everything is fine now. But let's understand the problem. There can be two problems. The first thing can be that suppose this line didn't work because of some reason, like this row is already logged by some other transaction, there can be some other problems going on in the database, we are not able to do the changes credit money to Y, we are not able to perform this transaction. So the after state will look something like that. So what we'll say after state, so I will mention it is a tick, that it is a perfect state, and it's a problematic state that will say 5 plus 0 is equal to 5. So in this situation, what will happen? We have to roll back in this situation because initial state was 10, but this time what we get after state equals to 5, because we are not able to run this row credit money to Y. This didn't work because of some reason. So we reach into this state and that is not a perfect state. So we will roll back the whole transaction. We will go back to this state, W1 equals to 10 and W2 equals to 0. We will reach back to this state. Now there can be one more problem that we can see, like suppose this transaction is going on, this whole thing is happening, we are changing these values, and at this time only there is another person, W3, came in between and changed the value of W2 to 7. Now after the completion of the transaction, what we are going to get? We will get the value 5 plus 7, that will make the values equals to 12. And again the whole transaction, the previous state was 10 and now we are getting, if the value is changed, then we will get the value equal to 10, and again it is not a perfect state. In this situation also we will get a rollback situation, and of course we will get rollback to the initial state. So this is all about the transaction. So in easy words, we can just simply say everything will happen perfectly or nothing will happen. So now let's understand the DB logging. So in our database we have two kinds of log. First is read log, or we can say it as shared log, and second one is write log or exclusive log. So there are some properties these read log and write log brings. So in the read log we are going to read the data from our database, and in the write log we are going to change the data, or we can just simply say we are going to update the data. What are the properties of these logs? So let's understand it with the table. So I had drawn one thing that I am having a shared log. We are going to understand it with the example of two users. So suppose the first thing is that I am reading a data, that means I am having a shared log. So the question is, can another person can read the same row? So it means if I am having a shared log S1, can another person can also have the same log S1 and read the same row? So the answer is yes. So it means that there are two users, user 1 and user 2, and they are reading a data from the same row S1, and they get the data. The first person get the data x equals to 10, and the second person also read the same data x equals to 10, and hence it is possible we both can read the data from a same row at the same time. Now move to the second point, that I am the one who is reading the data. That means user 1 is reading the data right now. Can at the same time user 2 can change that particular row? So the answer for that is no. So let's understand it with this second point example, that user 1 is reading a particular row x equals to 10, read the data perfectly fine. But what will happen for the user 2? User 2 have taken an exclusive log, like it means he wants to change or write the data. At the time wants to change the value x equals to 20. So what the DB will say that it is not allowed, you cannot do it because someone is reading the value x equals to 10, and it will make the problem of dirty read, because the value has changed from behind x equals to 10 to x equals to 20. That will cause a problem in the system. Now, so this is not possible. When I am having a shared log, no one can take an exclusive log on that particular row. Now let's move to the third point, that is having exclusive log. It means that I am the one who is changing the data. I am the one who is updating the data right now. Can someone read the data at that time? So the answer is no for it. Let's understand the third point. I am the user 1, take an exclusive log, changing the value from x equals to 10 to x equals to 20. I am changing this value right now. Now what will happen? Can someone, user 2, take a shared log? It means can user 2 can read the data? The answer is no. No reading is allowed at that time. Because if I am the one who is changing the data right now, then the user 2 will read the corrupt data. Like first of all he made the read call, then it will get the data 10. If the user 2 again make a read call, maybe it will get the data equals to 20, and that is not possible. That will create a problem in future. This is not allowed. Now let's understand the fourth point, that I am having an exclusive log, means I am again changing the data. Can user 2, another user, can also update that particular row? The answer is no, because I am the one who is changing the data. Can user 2 change the data? The answer is no. Only one action can be performed at a time. So the fourth point is, if I am the one who is changing the data, I've taken the exclusive log, changing the value from x equals to 10 to x equals to 20, can user 2 do it? The answer is no. X equals to 10, and we cannot change the value from x to 10 to x equals to 20 by user 2. Only one action can be performed at this time. So these are all the properties that DB locking are going to bring in the system. So we have covered the two topics in this video, that is of transactions and DB locking. The third concept is of isolation, that we'll cover in our next video. Thank you for watching me, and bye bye.